So I want this page, this set of problems has a lot of components, and so I want to go over them with you and make sure that you're solid on all these concepts here. So today I'm going to also kind of review, make sure you're good on how power changes, and then I'll come around and stamp you in a minute, and while you are doing numbers 1, 2, and 3, and then we'll meet back together and do number 4. All right, so let's start. This problem is about Macy's department store, and they have an estimate that 12% of their customers are male, so they are saying that that's what's the current issue. The marketing department, though, wants to suggest that they invest in a new marketing campaign that will include new male-oriented coloring and patterns. The research department then does that and conducts advertisements and decorating changes to see if the store in the test markets have an increase in the percent of its customers that are male. Okay, so first thing before I let you do this, what is the parameter of interest? What are we going to be what are we going to collect data for and then make an inference about? Correct. So we are going to, at the end, be able to say what the proportion, we're going to collect a sample and say this is, a location of the proportion of customers that are male at Macy's. Okay. I want you to keep in mind another thing at Macy's. Keep in mind, when are we going to be collecting a sample to determine this? When are we collecting this? Before we do all of the decorating changes or after? After. We're trying to see, has the decorating changes affected the proportion of customers that are male at Macy's? Proportion of customers. All right? So after you do all the changing, so after you do the new decorating, then you get a sample and you see what the proportion of customers that are male at Macy's is now to see if it has changed. Okay, so you start doing that. Do numbers 1, 2, 3. I'll meet back with you and do number 4 here in a minute. I'm going to come around and stamp you. Right, if it was two-tailed, then it would be 10%. Okay, if this was a two-tailed problem, this would be 10%. What? Because it would be both the 5%. So rejection region would be, the level of significance would then be 10%. Okay. You don't put all 10% up here, because what happened was they told me my interval size, which then places 90% of them in the middle. So then I know the size of the tails, and then I have just 5% that is going to be in the rejection region. Okay. Correct. If this was a two-tail problem, then the rejection region would be 10%. Correct. Correct. Okay, yes.
So if it's a two-tail, the lower 5% doesn't apply.
Correct. If we got stuff down here, this would not give us information that we're looking for, so because we are interested in finding if there is an increase. So we pretty much ignore that.
So that's why it's included.
Correct. That's why it's included just in the other part. Okay? Were you going to say something?
No.
Okay. Yes?
So the level of significance is that 5%?
Correct. Correct. All right. So there we go. So then on our little paper here, what level of significance did the research department use? The alpha that they used was 5% or 0.05. All right. So now let's talk about what kinds of things I want you to tell me here when it asks about advantages and disadvantages, okay? So let me kind of guide you through how you're going to do this process. Describe to the store manager an advantage and a disadvantage of using 2.5% alpha level of significance instead. All right, so going to a 2.5% alpha means that alpha has now done what? As far gotten bigger or gotten smaller? Okay, alpha has decreased. Okay, so let's now look at in terms of what has alpha decreasing affected. Okay, so you remember our little thing yesterday that we learned. Let's write it out. We're going to increase power. Let me do this one. I'm just going to write it like we know it, where alpha and 1 are the same thing. Beta and 2 are the same thing. Okay, and if I'm going up on the alpha, that's what's increasing my power. N is affecting standard deviation. Okay, now, the problem is, according to this problem, is alpha increasing on this problem? Okay, it's decreasing, so let me fix my picture. Okay, so it's decreasing, so let me fix my picture. I'm going to change the arrows. So the alpha is going down, so the type 2 is going up, and what is the power doing? Decreasing. Okay, so now I have a proper thing to determine what's happening. So, an advantage happens if an error goes down. A disadvantage happens if an error goes up. And then, whichever one power is doing, you're going to put that on that spot also. So, for example, an advantage would be an error going down. So what error do we have that is decreasing? Type 1. Okay, so our advantage is going to be that our type 1 error decreases. All right, very good. Because an error going down is good. Type 1 error decreases. Okay. So then a disadvantage would be in getting more of an error. So in this case, that would be what is happening? Type 2 error is increasing, okay? So I'm going to put that here. Type 2 error is increasing. Okay, now, I will add to one of these wherever power needs to go. Power is always a good thing. So if it's going up, it's an advantage. If it's going down, it's a disadvantage. So according to my picture here, what do we have? A decrease in power, so I'm going to write that here. We also have a decrease in power. Okay. Now, I could go into context and actually define what's happening here, and I'd go up and do that. Okay. Next. The store manager asked the research department to extend the trial period so that the decision can be made on 2 months worth of data instead of just 1. What is that doing if you are 2 months of data instead of 1? Good. Your sample size is increasing. So, how does that affect our power? Remember, if N is going up, then that's when we increase power. Okay, actually, you might remember it better from this picture here. If N goes up, our standard deviation is getting smaller. And so look at the size. From here, from this power to this power, we are increasing the power. Okay. All right, so that's what we had done yesterday. So, oops, that's wrong one. So let's put that there. So down here, what happens then? Power is going to increase. Okay, final thought. And this comes into just making some sense, and then they're going to do some more, the rest of these problems while I walk around and help you. Okay, so here we go. Over the trial month, the proportion of male shoppers in the store increased to 18%. So the company's board of directors decided that this increase was significant, meaning kind of quote unquote, there's proof that this decoration stuff works. and accomplishes increasing the male proportion like we want. Okay. So that now that they have concluded that the new marketing campaign works, why might they still choose not to invest in the campaign in all Macy's stores across the United States? Okay, give me one thought. Go.
So the increase wasn't, it was just a little bit, it wasn't like a huge jump from one year to another. So
Okay.
it's,
Okay, you're on to something there, but let's hear other thoughts. Go.
It was just that store, it's at like many stores, so it was increased in that region, not all over.
Okay. Okay, that is the most common thought, and I want to address that here in a second. That's a good one. Go. Scott.
Female, I think our females going to the store might decrease.
Okay, so the female proportion might decrease, which actually, are they making more money? Not, maybe not. That's a good thought too. Was that yours, Scott?
I think
Go.
it's like Asian and then you're overseas.
Okay. All right. So she's addressing the season. So now here's the things that's going on. I had several addressing the ability to apply these results to all the stores. And so you're concerned that these results may not be representative for the entire population of all the stores. Okay. So with that thought, that's actually not what they're going for here, because upon them running a test, we are going with the thought that they are using a representative sample that it would make it appropriate to generalize to all their stores. Okay? So in the event that this was a representative sample that they could generalize to all the stores, we're still, then we're not going to say that it's not applicable to all stores. It's more along the lines of this thought here. The increase is little. It actually also takes into account the proportion of women going down. So if the increase of proportion male shopper is increasing some, we may see that that's a lot of money, but we may not. I mean, is that money necessarily sufficient to pay for the incredible expense of redecorating all the stores? That's what we're going for, okay? So they may still choose not to invest because the cost of the program may outweigh the improvement in male customers. Look at how I spell outweigh. There you go, outweigh. All right. You get up here and you're not really thinking outweigh, right? That would be better. Okay. Way better, right? Okay. May outweigh the improvement in male customers. Okay. So that's what we're headed for. Now, these same thoughts are going to be happening on your next page of your assignment and on the warm-up. Okay, so I want you to work on these two things. This one's about the lottery tickets and the proportion of prize-winning tickets. And then your warm-up is about defective something or others. Okay, so do those.